All right, well, let's start our webinar. This is the third and final webinar for me, and there's one more coming, which we'll talk about at the end of this webinar. So this is the topic probably of most interest to me and really a lot of our customers. What do you do next? This webinar is called Real World Projects with Blockly, and we're talking about bigger uses of BlocklyProp, kind of out of the classroom if you're a teacher, or for products if you're a product developer, or if you're a hobbyist, whatever you want to make. So today, these three projects we're looking at are a vending machine, a robotic boat, and a drone pollination system. Sound like fun? I have two co-hosts with me today, and their video is live as well. The first one is Wayne Green, and this is his class. He teaches robotics to homeschoolers. He's also a federal agent who teaches electronics. Hi, Wayne. Wayne.
Hello, I had to unmute.
Okay, yeah, surprised you there. So they'll be muted and then they'll unmute whenever they want to talk. And go ahead, Wayne.
No, I'm unmuted. Now I'm muted.
Okay. Pleased to have you today. So you can see Wayne here programming with some younger students in Georgia. And our second host is the lovely Carol Hazlitt. Carol's been building robots since 1985, and she is an educator and a leader in robots of all kinds. She works with all kinds of products and tools. She's a contributing author to Servo Magazine and Robot Magazine, and you can find her all over the interwebs. And Carol, I think you're also a retired electrician. Did I get that right?
Yeah, I worked as electrician on 737s for Boeing for many years, but I'm retired from the phone company as what they called a P1 technician, and that was high band and broadband circuits. I would test them remotely by computer from the central office.
Really cool. So we got the federal agent and we have the 737 and broadband technician with us today. So a little bit of housekeeping before we get rolling, because we have so much to talk about, and I want this to be useful for you, our attendees. First off, this video is being streamed live on Facebook on the Blockly for Microcontrollers group, and if you're there, we are unable to hear you. You can only type questions, but I've got Jen Jacobs there is monitoring it. And also online here, I have the very good help of Kate from Parallax and Stephanie Lindsay from Parallax. Kate set up the webinar tool and the registration. Stephanie is answering technical questions, and them, along with our two co-hosts, will keep me on the straight when I get sideways here. So if you're using the Zoom tool, which is probably roughly 40-something of you or 50, and there are a lot of you that signed up. There are well over 100 on this webinar. Thanks for joining us. You have a couple of choices for communicating. If you'd like, you can type in your question in the Q&A button that's on your control panel, and somebody will answer it. You could also click through the pictures where you see us and make them larger, which might be helpful when we're sharing things. And there's also a chat window, which you can get to under the More button. And if you enable that, then you can chat. So, and whatever you want to talk about here, just ask your question, pose it. If it matters to you, it's important to us too. Sound good? Okay. Agenda for today. So we got a lot of things here on this list, and we're looking about 45 minutes to go through the whole webinar, and we'll include some time for whatever idle chit chat you want to throw in there. First off, we'll give you a super quick introduction to Parallax. I think many of you know Parallax. And then we're going to go through in some level of detail these three projects. And then I'll conclude it with the limitations of BlocklyProp. And we'll talk about upcoming webinars too. All right, so what Parallax is about, I think you all know this already. So what we've done that's very unique, aside from making our own multi-core microcontroller, the propeller, is that we have these wonderful applications of it in education. So we are a big manufacturer of robots that are used in schools. we teach students how to build electronic circuits and how to program these microcontrollers to do pretty much anything they want, as long as they have parts for it. So we get enthused when we see students getting inspired. We also do a lot of professional development. This year we've trained almost 500 teachers around the country. We did this for free, and they all took away at the end of their training their own activity bot. So we're seeing some of them today on our group as well. We do manufacturing, by the way, in Rocklin, California. And we really believe in learning by doing. We're a hands-on company. That's why we like programming microcontrollers, because we could build our projects. This is our team in Rocklin. So these are the people that answer your phone calls, build your products, take your sales orders, and keep our systems running, and run our CNC machines, our pick and place line, put stuff in boxes, you know. Thanks, guys. I bet a lot of them are actually hanging out on Facebook watching this. So you might be asking yourself a couple of questions as we get into this webinar. If you're a teacher, these are probably on your mind. How do you go from the classroom to real world projects? Because BlocklyProp and the propeller are a powerful combo. And I hope to show you that the concepts that we're teaching you on these little robots work in much bigger projects. Second, you're probably wondering about the language itself. And is it a real language? And I guess I ask back, who cares? It works great, and it does what it's intended to do. BlocklyProp is based on the Google open source Blockly JavaScript engine. And what Parallax has done is adapted it very well to the propeller multicore. Has a few limitations we will discuss. BlocklyProp generates C code, which you can copy out and edit for your other projects. So these questions I think we'll just answer as we go. This is the propeller multicore, and this is what Chip Gracie designed. He's the smarter half of my one and only sibling, and he's been doing this kind of thing really since he was a little kid, I would say. This is a block diagram, and what I'd like to draw your attention to is on the top you see these 5 blue squares. These are all propeller cores, or as we call them in Blockly, processors. And they have a shared memory and shared I/O pin bank. So that means that when you're trying to make a big program and do a lot of things in it, and all of these things you're doing, like reading buttons, driving servos, checking sensors, all take time to do, or generating sound, you can put them in their own processor, okay? And we've actually made this possible in Blockly, this cartoon-looking language. So when you combine these two things, you have a very capable embedded processing system, or physical computing system, whatever you'd like to call it. How about if we just jump into the first project here, and we'll just go over the project, and then we'll look at the code and a pictorial about how it works. So I'm going to start this video, and the audio on this is off, so I'll just tell you about it. Before I start it, this is a coin-operated desktop vending machine prototype, and this is intended for fundraising projects in office environments. So don't think about it like a soda machine in a parking garage, but more like the box of chocolate bars you see in your office where you leave $1 and someone's trying to raise money for their baseball team. So this would be an advanced version of that, because it holds a lot more choices of candy, and it takes your money just the same, and it's battery powered. So there's a prototype. Customer came to us when they saw BlocklyProp and thought it'd be the solution for their project. And I think it's a great example of a nice user interface and a really good conversion of pseudocode to real Blockly code and using off-the-shelf electronics. So let's start it, and as it rolls, I'll just tell you a little bit about it. So basically, the system's asleep until you press a button, and then it wakes up and it turns on the LCD, some LEDs, and a coin acceptor. Okay, so you drop some coins in here after you've pressed the button, the number you want for the candy, and then it displays the amount of money you've put in, And once the money total exceeds the price of the candy, that candy is dispensed. So this involves setting a pin, which turns on a motor, and that's done on a separate processor because these motors, which are DC gear motors, will have a little like auger or screw. They will drive until the candy is dispensed, which is detected by an optical sensor. So we want to get that right so that somebody doesn't get double the candy. So there's an input pin that waits for the motor's end stop to be reached. Once the candy is dispensed, everything is turned off and reset. The money total goes back to 0. Okay, so you could sell more candy. Interesting project? Okay, how does it work? What's going on here? This is a block diagram of all the pieces of that project. So what you see here, anything in teal, which is that light blue, is running in its own processor in the propeller, because these are time-sensitive aspects and we don't want to try to put them in the main loop. They can't be interrupted. And this is real parallel processing. So for example, the motor runs until it hits a limit switch and the coin acceptor is always ready. But the other things that are shown in gray, they happen in the main loop. So we got the 4x4 matrix keypad, and there's some LEDs for visual feedback. And the system counter is being monitored too in this, which is a special feature of the propeller. And there is a speaker which plays tones when you press buttons. So what does that code look like? Let's just open it up. And normally with these kinds of commercial or quasi-commercial projects, people aren't very willing to share what they work on for good reason. But there's a lot more going on than what I'm showing you today. But these are just some that have been made available to us. So here's your Blockly code for this project. Just kind of waiting for it to load. I think I've got an internet freeze. Ah, there we go. Okay. So let's look at the main loop and just see what's going on. And if you haven't worked with Blockly before, it is a lot of fun. It's as fun as it looks. You just drag out these blocks and configure them. So we won't go into too much detail with this code because it's always a little difficult to explain the way something works when it's not your code. But having it in Blockly really does help. So you can see in the beginning of it, we just initialize an LCD pin and then we stuff some price values into an array, which we'll index later. And then down here, this is kind of neat. So the dispenser and the coin acceptor are running in their own processors. So the way you do this in Blockly is you put a new processor block, you just drag it out from here under control into the workspace, and then you create a function, and then you drag that function back into the new processor block. Okay, so for example, this dispenser, if I can go find dispense, here it is. Okay, this is a loop that runs forever in one processor. And it looks like this one is turning the motor on and then stopping it when the limit is reached. And then the other one that runs in its own processor is the coin acceptor. Of course, you don't want to miss getting money, right? But the main program loop, which usually in Blockly, everything just starts at the top. When you see the first repeat loop, because in some way all programs repeat, this would be the main program loop. So it looks like we see the machine's awake, we turn it on, fire up the LCD, turn the lights off, then we set them, and then we see which button's been pressed, we display it on the LCD, and at some point in here we set some values so that the candy can be ejected. Pretty neat. Okay, so that's our first one. Oh, by the way, so how can you go from the classroom to real world? That project uses different tutorials that have been published on our Learn site. And I want to draw you back to these because this is how you can build bigger projects. Every project you build is a selection of smaller pieces that you've made work on their own. So there you saw the 4x4 keypad. There's a tutorial for that. You also saw a coin acceptor, and since we helped a customer, we made a tutorial for that as well. You can buy these things off Amazon. I think they're pretty cheap. So this is a 2 or 3 page tutorial you want to check out. And then this one is from John McPhalen. This is using the system timer. And there's a 45-second, I guess, timeout where the machine goes to sleep. And that clock is accessible in your Blockly code. So take a look at all those. Okay, want to move on to something a little different? Okay. All right, so this is an autonomous surface vehicle, and this is the boat, as you might call it, that you can see behind me. This is a project that is on no particular schedule, but it's one of my own, and I've been working on it really for over a year, but that's okay. The purpose of this project is to deploy this ASV, I'll call it from here on out, into Lake Tahoe and have it navigate to different locations under GPS control. At each different waypoint, it will have the ability to collect environmental data, things like temperature, pH, turbidity, or chemical concentrations. So whenever you show pictures like this, everybody says, I want to see it run. So let's see the boat go. Here's the boat going just a week ago in Donner Lake, which is the little lake nearby Lake Tahoe. And this is about 25% throttle. It's a very torquey system, which I'll show you a little more closely in a minute. And this is totally under radio control at the moment. So it's a very stable, watertight craft. And really, it's just been a lot of fun just to drive the thing around, but I need to move on now to the autonomous part of it. So why am I doing this? Any of you might be familiar with Lake Tahoe. Maybe you've been here before. So Lake Tahoe is the crown jewel of the Sierras, and this is an oligotrophic lake, meaning it's largely free of nutrients, and that gives you great clarity to depths of 70 feet or more, okay? It's a high altitude lake. The mountains surrounding it are composed of granite. However, there are also lots of people that live around this lake, and the humans bring with us runoff, and that runoff is fertilizer, it's rubber from the road, it's tailpipe emissions, it's dust from the Gobi Desert, it is whatever, and it all makes its way into the lake and affects the clarity of this lake. So this lake has been studied for many years. Has anybody been here? I bet a few of you have. So here's a graph, which I copied out of UC Davis report. UC Davis has been studying this lake for, gosh, maybe 40 years. And one of the things they measure is depth. And they do this by dropping what I would call a dinner plate into the lake. And then when the person on the boat can't see the dinner plate anymore, they record that as the value. And you'll notice a trend here, which is good, which is the clarity seems to have flattened, and maybe it's even increasing, okay? Which might mean that some of the recent efforts to control runoff are increasing, right? But there's something else happening at the same time. Can you guess what that might be? It's the temperature of the lake. The temperature of the water is now increasing, okay? Last year, kids were swimming in it all summer. Normally, we don't see that. But with warm temperatures, what do we get? We get more invasive species. We get the wrong kinds of diversity. We get crawfish, bass, catfish, and these things have the potential to destroy native species. With warmer temperatures, we also get more algae growth. So now measuring water temperature is actually of interest to us. And this is how it's done at the moment. We have a big steel boat or aluminum boat from UC Davis, which goes out with people on it, and they take measurements. And then there are a number of fixed monitoring stations. So of course, what I propose is that we use a robot to do this. And my interest primarily is the BlocklyProp side of this project and to show what BlocklyProp can do with GPS navigation. And once that is all working, then I will bring in the scientists to say what they would like to collect.
Ken,
Yes.
did you have to get permission to run your boats on the lake? Every lake that we run our boats, our RC boats up here, we have to get permission.
Yes. We have to have quagga mussel inspections when we put anything into the lake except a kayak, and they weren't really sure what to think of this, but they inspected it anyway. So it was inspected, now it has a tag, so we do have to do that. And going forward, it'll have to be inspected again, and then I'll probably have to get permission to run it autonomously. Yeah, I think it's the same all in the Northwest now.
Yeah, ours was just because we were putting electric motors in the water.
Yeah.
And they still thought of those as being greasy, polluting.
Yeah.
Like the gas boats are.
Yep. Yeah, it'll get a lot of attention, sometimes more than I want. Anyway, this platform comes from a company called Manifold Robotics. Initially, I was building my own until I discovered them. So they make the boat, and just did a little negotiating with them and got one in blue for Parallax. And you can see they're already into this kind of thing. This is their business, which is ASVs for research. So a little closer look at the actual project. This is the operational plan I have in mind. And you know, as I look at this, I admit to myself, well, gosh, can't you just like throw a bunch of computers and cell phones at it and make it all work? And I suppose you can, but I really want to know how it works, and I want to write the code for it, and I want it to be done in Blockly. So I'd like to have control over all the pieces. Basically, there's a guy on the shore who's holding an RC transmitter. It's one of these, okay? And this only works up to a mile. And that RC transmitter can control the boat, but then it can switch over to GPS waypoint navigation just by flipping a channel on the radio. And then at that point, when it's autonomous, I will have its location identified to me on the shore. And the little person is holding an OLED module, which shows the latitude, longitude, elevation, heading, how fast it's going, where it is, in case I have to go out and get it. So in a huge lake like this, there's really not much to hit. There are no boats in it during most of the year. And it's very little obstacles as well. So it may or may not have sensors on it. I've not decided. So it just gets GPS through triangulating all the satellites, and then it sends its location back to me. So how does all that work? Okay. Well, first off, let me back up a little bit. A project like this is built in steps. I often get asked by teachers and customers, how do I do a big, impressive project? You build it in little pieces. You make the little subsystems work, and then you make the whole thing work together. So the first step of this project was to make it work under radio control. All right, so this is the box that sits on top of the boat, and it's a Pelican box which seals up. It has a RC receiver in it, and you'll notice that receiver is wired directly to the propeller board, okay? And then this gives the propeller a chance in Blockly to mix the signals the right way for the ESCs, so that it has a nice driving user interface. And also so that I can, of course, control it autonomously. These are electronic speed controls, and then the wires going out go to some really big LiPo batteries that are in the hall that will provide enough power for about 16 hours of runtime. And so the next step here is to add the GPS. Let's just look at the code really quick for this. It's kind of neat. So here's actually, let me turn on the board here. We'll see if things work. I've had some port issues with my computer lately. Okay, so what you're looking at is just a piece of code which receives the pulses from the throttle and the aileron, or radio, on 2 I/O pins. People always wonder how things like this work, but it's all really, really simple if you just research it. You get these 2 pulses, and then I provide a mixing value, because what I want to do is provide throttle on the left, and then the right can just be steering. So I map the aileron value to a new range, -200 and +200. Then I mix it in with the throttle so I could steer this thing. So we could actually bring this up. I have a graphing block inside of this, and you can see how it works. So let's see if we have success. Whoops, I'll re-download that. Oh, what is that? Unable to connect to device. Ah, must be my new hub. Try one more time. What I want to show you here is the graphing feature, which is so neat. Okay, I guess it's not going to happen today. It's first rule of demos, right? They should never work when you want to show them. But probably, I'll give this a look as we get back into the end of the webinar now.
Hey, Ken, John
Yeah.
Kaufman has a couple of questions for you about the boat that you might want to answer now.
Oh, so I don't know about sail. Sail would be complex. So the benefit of a system like I have is that it steers just like a robot. 0 turn radius. So with no rudder and no forward momentum in any direction, you can stop and turn wherever you want to go. So that's why there's no sail, no plans for that. That's a good idea though. And then measuring dissolved oxygen and pH are tricky to keep sensors and calibrated. I don't know what sensors I'm using yet, and I'm gonna have to talk to the pros about that. So they'll figure that out for me. Okay, so RC works, and these are the thrusters. So as I mentioned, this is like a skid steering system, 0 turn radius, which is very easy to control. Here's another video of it actually running in the lake at another time. This kind of, this funny guy here just kind of picks it up and drops it in the water. It's a very cold day, must have been 20 degrees. I always put GoPros on these. I'd like to add a video transmit receive. So just threw it out in the lake, and I was collecting some video while driving, seeing how it does in the waves, and it does really, really well. So it could definitely outrun the waves if it needs to. What do you think, Carol?
I'm thinking of putting a GoPro on mine. I'm doing essentially the same thing Ken is doing, except I was a little further ahead. When it was, mine is still an Arduino. I'm going to change it to BlocklyProp, but it's called a RoboTug. And here's the electronics in it. And it's an Arduino. Here's the GPS in it over here. If you can see it up in the corner here. So it did both autonomous and regular, and it's a twin screw, like he's talking about, that gives you like differential drive. This was a tugboat kit sent to me by a company called Zip Kits. So it's essentially a box of wood, and I had to make it into the boat, which was fun. This is sort of what it looks like.
So Carol and I are probably at the same stage of this project right now, and I hope to be working with you, Carol, on the GPS part.
Yeah, and I'm going to be converting mine to a propeller, taking the Arduino stuff out and converting it to the propeller so I can make it fit our project. In fact, when it's done, I might even just go ahead and send it to Ken so you can have two boats out there.
You might get there before me at my current rate.
I don't know. I've got a lot of stuff going. I'm still trying to get my balancing one going. And
so here's the second part of the project. This is the GPS transmitter. So the left side would basically be in the boat. The right side would be on shore in my control panel, which I have built up, and it looks more kind of like this. So I might end up just driving the boat with my own homemade system, my own joystick, and that's also an OLED. But the proof of that project is shown here. So sitting outside on top of my car at this latitude and longitude is a GPS module and a board similar to this one with an XB high-powered module on it. These are the 900s. And they claim in their data sheet up to 20 miles line of sight communication. I really only need about 10, but I have tested it up to 10 miles with line of sight, and it works great. And what's so neat about that, again, is the code. in Blockly is so simple. This is the code for the GPS transmitter. So what would be on the boat? So basically, this is the main loop. And if the satellite is there, then it gets the units, it converts them because initially they're very big numbers. And if you're hooked up to a computer, you could display them. And then it transmits them on XB. And the transmit function in XB is in transparent mode, which means you could just send a bunch of data out serially on the XB unit, and it will show up perfectly on the other side, which makes this so easy. So that part's working. And the next step, as I mentioned, is to integrate the GPS. Okay, so how about the building blocks for this project? This is the GPS reference in the Learn tutorial reference guide. It has examples, code examples. You could work from that nicely. And then the OLED I showed you, and then the motor control would be from the activity bot.
Ken, could you elaborate a little bit on the motor control and what the sources for the motors you're using?
Yes. So the sources for the motors are Blue Robotics. And yeah, so they're Blue Robotics T200 thrusters. They're about $120 each. And they have an electronic speed control connected to them. So the input to the ESC is the same that a servo gets. It's just a pulse every 20 to 50 milliseconds of 1 to 2 milliseconds in length. So does that answer your question?
And you're using the activity bots library for that?
I am not. I'm actually using Pulseout.
Okay, you're using Pulseout for that. Just for clarification.
Thanks.
Thank you. I was a little amazed there for a moment.
No encoder feedback. Wouldn't that be neat? So Johnny Mac asked a question. I'm using transparent mode. Yes. There are a couple ways to use XB, but I found transparent mode works great for what I'm doing.
In answer to that same question, on my Robo Magellan, which I've already put a propeller on and GPS on, and I'm using a flip for it. I have some code, which I'll have to look through all the libraries to find already on the BlocklyProp website for using H-bridges with DC motors, because I took my ESC off of the truck I'm using for Robo Magellan and put on an H-bridge. So I have 15 amp.
So, and if you're doing that, then you have also probably a PWM command you could get in Blockly, which is right here. I think you already know that, but for the others. So there are a bunch of ways to do things here. Yeah, motors might be PWM, they might be steppers, or they might be servos, and there are commands for all that. In fact, this next project, so now we're stepping into a real commercial project that's very impressive and has gotten a lot of attention lately. This is from Dropcopter. Their website is dropcopter.com. They are a robotic farming company in Northern California up in Anderson, which is by Red Bluff. And Dropcopter aims to increase fruit production through assisted pollination techniques, basically helping out the bees. So that's right, this drone drops pollen into almond trees, or if you're a farmer, they're called almond trees. And the same technology could be used in with cherry trees, with apple trees, or even perhaps in some way with grapes, but more with a video camera. So what are these guys doing? You're looking at an almond tree flower. So let me tell you a little bit more about these before we talk about the project. These are the most economically valuable bee pollinated crops. In fact, almonds are nearly 100% dependent on bees for pollination. And if enough bees are there, 90 to 100% of almond flowers per tree can develop into nutlets. But none will develop if no bees visit the tree. However, bees have been in decline in California. There's a big business, which is the commercial renting of beehives, where they'll be brought out to orchards such as this one and left there to pollinate the trees. So what Dropcopter does is it helps the bees. Since bees are in decline, Dropcopter will also disperse pollen throughout the orchard. So the drone sprays it out, the props wash it down, and then some of it makes it right into the flowers. And then the bees also pick it up with their feet or however they pick stuff up, and then they move it into the flowers. And this has been shown to increase productivity by 10 to 15%, which is pretty massive when you're talking about a very dense, valuable crop like almonds. So just last week, I came across this while preparing the webinar. Dropcopter came across another $250,000 investment from the Genius New York 2.0 Accelerator. And I know they're in the running for a $1 million support. You can read about this on their website.
It's going to be more important in the future. Since 1998, there's been a 74% drop in the biomass of flying insects, including bees. If you've noticed lately, you've noticed there's less flies and mosquitoes around too than used to be. But the good insects are going too, which is also going to affect our bird and bat populations.
Yeah, I mean, I think even to some extent, maybe farming or grape vineyards or just landscape activities mow down the plants that bees need.
I think all the flies and bees moved to Southeast Georgia, the mosquitoes. So.
I bet mosquitoes in Georgia are as big as this quadcopter.
They're just about.
So this is the drone. I guess it's actually a six-bladed hexacopter. And the story behind these guys is that they were building their project for about 3 years with Arduinos, and were really getting stuck in the code. Partially because it's C code, and then the other part of that is because, well, the Arduino can only do so much. It's a single-threaded processor with interrupts, and the code became a real mess for them. So they discovered Chip, and Chip brought them over and turned their 3 years of work into 3 hours of demonstration and got them working. So the solution was to put a flip module on this and use BlocklyProp. Let's look at the actual craft a little bit. And I might have the explanation out of order here, but I'm close enough. I think we all get the idea here. So how does this thing work? So the pollen sits in this clear tank you see in the middle. This pollen is expensive. It's like $1,000 a pound, so you have to manage it very carefully. So what their system does is it first receives an input from the RC receiver, or it's from the Pixhawk autopilot system. I'm not really sure how that gets there, but it's just a pulse width using the pulse in command will decide to activate the whole system. So the flapper motor opens, which is down here, all right, which says the bay is open, and then the auger begins, which feeds the material down, and then we got this high-speed brushless motor on the bottom called the slinger, which fires up and then starts spraying the pollen out, and then it's perfect because the propellers just wash it down so it gets to where it wants to go. It's a really nice system. And what they've done that's really so special here is they've come up with a nice set of mechanics. This is probably their last generation pollination machine, but I know they're building some more because I'm going to see them later this week of a new design. So Dropcopter's in the lead here. Block diagram. Chip wrote this code in Blockly for them. We'll take a look at it in a minute. And again, this light blue are all processors that are running their own thing. And I've tried to provide you with a little bit of help here so you can see the kinds of signals and how they might have timing dependencies that you'd want them to run in their own processor for. For example, this auger motor is a stepper motor. Okay, so you're always pulsing, turning groups of pins, 2 pins of 4 on or off in different pairs to make the motor turn. In between that, you have a delay, all right, which determines the speed of the stepper motor. And you don't want this process to be interrupted. You want it to run freely on its own because the stuff that you are dropping is so expensive and you want to feed it very carefully. So the slinger, which is the brushless motor on the bottom, it's the same thing. Why not just put it in its own processor and then give it signals like a servo so that it could just wind up and spray. And then of course the flapper, a servo signal, that could probably run in the main loop because, as I'll show you here in a minute, some of our libraries in Blockly, which use our C libraries, have also the ability to launch a processor and then maintain the signal to the hardware. And pilot activation also is in its own processor. So the buttons here, which are in the main loop, are a method to program the machine. I think that would be like feed rates probably. So if you have to maintain all these signals reliably all the time, it's much easier to do it in parallel than try to put this in one big loop. Let's get a look at our code. This code is really pretty, partially because Chip wrote it, but also because it doesn't use the uglier color blocks. I'm sensitive to certain colors, but check this out. You can see that the slinger speeds are part of an array. And I think all you do in the main loop is with the buttons is you pick the speed, and then that comes out in the slinger function, wherever it is. So here are the things that run in their own processor. Down in the main code loop, on the left side, it looks like you're checking the button, and based on that, you are programming the auger feed rate and then the slinger feed rate. So it's pretty neat. And then check button is its own function down here. So if Chip were here, he could tell us more about this code, but it went together pretty nicely. In BlocklyProp, by the way, you can just right-click on things, and then you can also collapse blocks like this. And this block centers your code. You can also do things like clean up blocks to make your program appear in a line vertically. So that's how you manage bigger projects. We're seeing customers now develop much larger code in BlocklyProp, and they need to understand these controls so they don't get overwhelmed with the screen of color. By the way, the C code generated by this is right here. Okay, so for each of our blocks, the JavaScript that we code the blocks with generates C code. And you can copy that C code out and then put it into simple IDE and then modify it and run it. But soon, maybe the end of summer, I shouldn't make promises because my team is hanging out here, you'll be able to compile that code with the online version of BlocklyProp and download it. But you can't go from code back to blocks. Any questions on this so far? Want to hear from the farmer? Let's see what he has to say here. Hopefully the audio comes through okay. Maybe you guys can let me know.
Ken, we do have a couple of questions before you push go there.
Oh, okay. So yeah, Jean, answer your question first. So the propeller has no interrupts. It has 8 processors that run in parallel with the shared system clock. So let's say you're monitoring a button or you're waiting for a serial string to come in, you would just run those in their own processors. And this eliminates the hassle of figuring out what to do when interrupt occurs and makes your code a lot easier to read. James, answer to your question. So editing the C directly and having it reflect to the block, not likely to happen. That's a one-way trip for reasons I cannot explain. But I guess you'd have to then have the C code write JavaScript, which would generate the blocks. But we've been asked that before. But once you go into C, then you're on your way.
I found it, though, fairly easy to take a C code program and then just go through the BlocklyProp commands and figure out how to put a BlocklyProp program together from a C program. That's how I've cheated a few times to make a BlocklyProp project out of one of my old Arduino projects. I've been doing it a lot, and it's not that hard to do.
Thank you for pointing that out. And for those that are working with interrupts already, I draw your attention to this tutorial. This is with our C software. It's an example you can check out. So these are all on learn.parallax.com. And you'll find both C and Blockly. So this is Matt Bol, and we'll let him talk here for a minute. And let's just see what he has to say. Hopefully the audio works okay for you.
So we started on this project 4 years ago. I've been involved with agriculture for a number of years and was spinning around in my head how you could use this and, you know, what is something that's lightweight that would have an agricultural application. Somehow the idea came about doing pollen because it's very light. So we started on this project 4 years ago, and it's developed over the last 4 years until we've come across this. Before, it was all done with potentiometers, which are very heavy and took a lot of packaging. And just by chance, I met Chip from Parallax up at the Farm Bureau. So we ran into a problem where we had a design that wasn't quite working, that was very cumbersome, and we ended up taking it up to Chip's shop in Red Bluff, and he was able to look at it and immediately determine what device they had at Parallax that could fulfill our needs in this agricultural product. And within, I would say, 3 hours of my pilot Michael and I being up there with him, he was able to get the thing working, which was just amazing. So what we have now is using a Parallax chip that's programmed by Michael, our pilot, who has no programming experience at all. And we're both older guys, so we're not used to doing this. He was able to learn how to do this in an afternoon. And because of this chip, and because of Chip and Parallax, we're able to go through, and he put this in a sequence that makes sense for the machine on how to operate efficiently. So it turns on the slinger, it opens the trap door to the auger feed, so there's no loss of material. So what happens is we get to where we're going to pollinate over the top of a row. The spinner turns on, which moves the pollen out towards the vortex of the blades. The trap door opens, and then the auger starts to turn. We set a predetermined ground speed. We can change any of the parameters on the auger or on the spinner to calibrate it however much material we want to put out in the spread, and then fly down the rows and apply our material at about 8 feet above the canopy, which is probably one of the more difficult things people have done with drones in a commercial setting, because we're in an orchard, there's trees, there's telephone poles, so there's not a lot of room in 8 feet to compensate for issues. So it has to be very precise, and our ground speed and everything has to be calibrated and be right on. And it's worked amazingly. It uses low power, and it was very simple to install. The other thing is we've got some updates we want to do with it, and just by adding a few little components, we're going to be able to make this much user-friendly so anybody can use it. And we're farmers, so we need something that's very reliable and easy to use, and it already is, and it'll be simple to make it even more useful. It's an agricultural operation, so we've had this thing out where it's 35 degrees up to 100 degrees, so it's got to be able to handle temperature extremes. Plus, the material pollen gets everywhere. And the thing to remember with pollination or bloom, your window is very narrow, so everything has to work, because you can't afford to miss a couple days, and if you miss a week, your whole season's over and you've done nothing. It has to be durable and it has to work, and it does a great job. And they've been just super helpful. I can't say enough about their assistance that they gave us throughout this whole project, and it's been invaluable. Was doing pollen, because it already is.
And I'll just advance this on to the next slide. Farmers are such humble guys, aren't they? It's amazing. Anyway, yeah, I think it really helped him out, and Chip gave him some guidance, but he's a really good example of some of the people that are being attracted to BlocklyProp right now. Programming is not their main function. They're biologists, they are farmers, they are sometimes roboticists, but it's easy enough they could use the system very well with no prior experience. So let's talk about some of the limitations with BlocklyProp. We know what it's really good at. So the limitations really depend on, I would say, the hardware you're trying to program with Blockly. And what Parallax has done is made Blockly very functional for the propeller multi-core. All right, so our Blockly would be probably useless programming, let's say, a C language for a computer, because the list of things you would expect for C code in computer programming are very long. but what you expect in a microcontroller is entirely different. All right, so this is our pretty much our main list of shortcomings and how we handle them. First off, there's no floating point, and you can get around that by using integer math. So at 32-bit numbers storage, you could always multiply up and then divide at the end of the equation, or just work with integers and lose the decimal side. It depends on what you're doing. At the present moment, it's online operation only with BlocklyProp, but this summer we're releasing an offline version. And this is important for any teacher who's hanging out here. We know you have to have your school IT departments approve Parallax software. It is COPPA compliant, but what we're seeing now is school districts are putting their own agreements on top of COPPA and then asking us to sign them. So we have several such agreements in process right now that we're working through, but if you don't want to use a cloud version, you'll have the offline version soon. And then third, it's no code optimization. I'm not sure how relevant this is. I'm not a professional programmer, but I've not run out of code. Gene, for debugging, your method here is to use communicate blocks and the graph blocks to see where you are, to show different numbers, variables, etc., things that you want to show. One thing it's missing is real detailed, extensive I2C one-wire support. There are two ways we handle this normally with BlocklyProp. If it's a popular part, we'll simply make a library for it and build a block. And if it's not, you might be able to program for it anyway using our serial blocks or our pulse blocks or analog blocks, etc. We've had few requests in this way, but occasionally come up. And then just the graphical interface for handling big projects. As I mentioned, you can use the right-click features to clean up your workspace, collapse blocks, hide them, change inputs from external, which is very long, to inline, which are more stacked. And then it's a visual programming language. I consider that a huge benefit, not really a limitation. But if you want C, you can copy the code out, of course, and just program in C. So Ken Nikula asked, is there a good index for Blockly projects online so you can look for ideas? So the place I would take you, Ken, and I'm just going to take you there really quickly because we still have a few minutes, would be into Learn. And then if you click on Tutorials, Languages, BlocklyProp, and then you look at the propeller board block reference, this is the guide that you want to use. So all of our blocks are kept properly documented here, thanks to Stephanie and Matt and the hard work of our whole team. So this is a great idea, great place just to get block reference. But for projects, you could go to Tutorials, Language Specific, BlocklyProp, and this is at the moment where we're keeping all of our projects. You could just scroll down here and you'll see a variety of things. And this list is growing like crazy. You can also go to the Blockly for Microcontrollers Facebook group if you're into that sort of thing, and we're posting things there. James is asking about custom blocks for Blockly. Can you create your own for BlocklyProp, or does that only happen on the Parallax side of things? So what you could do, there is a large developer group, and we have a GitHub for BlocklyProp. At the moment, we are controlling the distribution of it so everything works right. So if there's not a block and you'd like one, you can go to the GitHub for Parallax, and you can post an issue there. And maybe we can make a block for it or work with you to figure out how to do what you want to do. So because it's a cloud system and it runs on our servers, it's controlled by Parallax, but this is also important because the users in school need things to work right. So we can't just spray out blocks all the time. But for example, John McPhalen wanted access to the system timer, the clock in Blockly, so we built that block in for him with his help. If you want to play around with blocks, so the offline version, all right, so you could download this whole thing on GitHub. So if you want to work from our code base, you're welcome to do that. It is open source as well as the propeller chip. Everything is open that we do. You can grab it all, look at the code base. If you just want to play around with blocks, I would say go to the block factory. and see what you could do to make your own blocks, because you can make blocks and run them online. It's a lot of fun. Here's a request I would throw to you that Google has posted on their page for Blockly developers. It is, we'd love to see Blockly out in the real world, from teaching programming to students to controlling heavy machinery in a factory. So Blockly is every bit as reliable as any other language, provided the coders who generate the code that compiles do a good job. And so that's what we do. And my challenge to you is to find a real project for Blockly. Do impressive things. We know it does robots great, but yeah, do something big. We're ready to see some more big projects with Blockly. They're starting to show up. You can print out the code as text. This is a question from Gene. Yeah, just switch over into code view, and in here you can select all this and copy it out, and then paste it into an editor of your choosing. So here's the best way to get started. Here's the sales pitch for you. It's really important that you just get a kit and start doing something. The Flip Try It kit is the best way. It's 80 bucks, and you get the Flip module, which is only 30. All right, that's this little module, and I like it because it's the most versatile of all of our products and lowest cost. So you could get started that way. Just go online and buy it. The Flip module is currently on sale for 20-something. Jump in and do it before the price goes up. Moving on. In 1 month from now, we have another webinar, and it's Advanced Projects with the ActivityBot 360. This is a request from teachers. So once they go through all of our tutorials, what else can they do? And we'll be showing you at this webinar, which will be run by Matt. We have a very active Blockly group on Facebook. I invite you to jump in here. We're just hitting 700 members. And the most common request, just like the one I had here a minute ago, is for more projects. And really, to do these systems properly, like we're doing, to make the hardware, to make the software, to make the tutorials, to provide the support, it's a big effort. It takes a lot of years, actually. So the Propeller 1 came out in 2006. Propeller 2 is finishing completion right now, but it's taken us this long to get the Blockly system to work. Blockly only came out in 2011. So a few years later, we adapted it after it matured. Now it's growing. Now you see the projects. The projects are the same thing that I want to do every day. So projects are coming. And that's what people ask us for all day, is more applications, more applications. And that's how our team is spending our summer in Parallax. We are not teaching any classes. We're just working on projects and applications for Blockly. If you're a teacher and you want some help, you can call the Educator Hotline. This is operated by our educational staff, usually Kate, Matt, or I, and we will answer it just about any time. This is great for the East Coasters and the international customers who want to call at what would be stranger hours for us. If we're around, we're happy to answer it. Or you could email learn@parallax.com. This is important because we don't want you stuck in class if you're having an issue. Sometimes you can lose the student attention very quickly, but what we've given them opens the world up, okay? So the opportunity for failure is high. Things have to be wired, programmed, powered correctly, and there's a lot of room for error. And educators learn alongside with students, so don't be afraid to call us or even put your student on the call with us, or send us an email and we will reply right away. So Carol asked, yeah, a couple things to point out that are very relevant. The search engine in the projects currently stinks. We're looking at a new search engine to supplant over what we have. So tomorrow we're gonna look at that more closely. Changing some of the spin books like PE lab kits to BlocklyProp. I should have Stephanie answer that, because she's our editor and she knows this part more closely.
Well, Andy is currently working on a book for the ActivityBot first, but he has a lot of material that was written originally like What's a Microcontroller that he has also moved toward the propeller in C, and will be following that up with Blockly as well. And as much as possible, we are making books adaptable to use with either the activity board or the propeller flip if they're not robot specific. Are you interested in some of the advanced topics that were in the PE kit specifically? We can address that as well.
No, I'm kind of going through that on my own right now, doing some of the projects like PingDAR and that from the PE books. The whole series, like Stamps in Class, What's a Microcontroller, Process Control, all of those books are kind of what got me really started into programming.
Yes, indeed.
I
Process
learned
control.
a lot of my programming from Parallax projects. I've probably bought, I think there's only 2 Parallax products I don't own, and that's a Penguin and the newest version of the Prop Scope. I even have an old stamp bug that's called a Basic Stamp 1 done by Milford Instruments, which I've never been able to find out yet. Did Parallax have anything to do with that, or?
That was the first robot I worked on. But Carol, I might have something for you.
I even still have all the SX chips.
While Ken's looking for something, know that process control is a topic that I very much want to get back into and with an updated approach, because I think this would be a very easy way to not get so deep into the coding that you lose sight of the fact that it's the assembly line processes that you're trying to control. So
yeah, well,
yes.
process control would really show off the multi-core capability.
Absolutely. So that's definitely on our list, but I don't have dates for these yet.
Stephanie really nailed it there. If we could do whatever we wanted to, we'd be making these tutorials as fast as we could for you right now, because every time we go somewhere, the customer brings out the books. That's the books, just like you did, Carol.
Andy has currently been forcibly sequestered and chained to his writing desk.
So yep, our customers have directed us, and that's where we're going. So Carol, to answer your question, I did discover here, this is the remaining inventory of the penguins.
Oh, you're kidding.
So you will be in luck as soon as I have time to sort through it. I know you've been interested in it.
Yes, that's the only one I don't have.
I know you are. So before we close out, I just wanted to show you the code that I did get running here for, this is the radio signals from that BlocklyProp code for the ASV. So this is a step in development. It's great to use the graphing function to display the data that you're seeing, and then you can really figure out what to do with it. It's really nice for sensors. So I just had to plug the board in, and then it was good to go. And if you turn this thing on, you can then hear the motors, which are quite loud. We'll see. Whoa. Okay, you get the idea.
And
So
if I ever get my PID finished, you will be the first to know. I did figure out one thing. It's too hard, especially since you don't have floating point, to use, it gets too big to use Kalman filters or the regular PID filters. But there's a very simple filter called a complementary filter. And I'm getting ready to try that on the robot and see how it goes.
Great.
And I think it'll be fairly easy to do in BlocklyProp. I've already started playing with it in BlocklyProp. So I may soon have a working PID.
Yeah, great. I haven't gotten there yet myself. But as the needs grow, like you're experiencing, we'll be figuring out how to deal with them.
And like you said, you just break it up in small pieces and get the pieces.
Exactly.
You got the I and the D part working.
Mm-hmm.
The P is the hard part.
Yeah, and so for the teachers out there, when the student brings you, a big mess of a project and they say, hey, it doesn't work. Well, there's a problem in their circuit or their code or their power supply. And you just have to direct them to go back to the pieces that did work, to disassemble it and then build it in little bits. And that'll help them debug. So for the attendees out there, do you have any questions that we didn't answer? We still have near 40 hanging out online. I want to thank you guys, all of you, for joining us today. Your time is valuable. We will say hello to Andy for all of you. And it's good to see so many well-known names on this list. It's really impressive. But if you have any questions, you can raise your hand. You could use your microphone and ask them. Yeah, hopefully people acquired a lot of knowledge along the way today and got inspired to do something.
You want a set of propeller guards?
I would love that because my quadcopter behind me has guardless.
Well, I know you have some of your own, some Parallax ones, but they're kind of flimsy looking maybe.
I'm not partial, send them over.
Okay, and these are ducted. So the little bit of testing we did get to do, it flew great. So I'm taking, next time we get weather like this, we're gonna fly it somewhere where we can really show you how it works.
Great.
And I'll send you the STL files for it too.
Okay, that'd be neat. Well, Wayne, thank you.
Thank you. This was awesome. I mentioned to you before, I'm really a newbie in this area, and I mentioned to you that sometimes the kids learn something of the day after I learned it myself. But I'm looking for ways to incorporate more high school level kind of stuff, and that was one of the things I was looking for out of this webinar, and definitely nailed it. One of the ideas running through my mind here. So the part of Georgia where I live is on the Atlantic coast. My house is only a half mile from the Atlantic Ocean, which gets, trying during hurricane season, obviously. The kids here, as well as many of the adults, really interested in oceanography kind of stuff. They just the area where we are, marine biology. So I've been trying to figure out a way to put together, say, a buoy kind of situation. We have a lot of rivers out here. I probably wouldn't be able to put a buoy out into Atlantic itself, but we have a ton of rivers, coming off the Atlantic. We do have a NOAA station here. University of Georgia has a marine extension here. We have the Georgia Sea Turtle Center. So a lot of opportunities to be able to try to do science with the robots. I'm teaching them the science of the electronics and the robots, but now I want to be able to take the high schoolers and transition to where they're using that to do science. So this was perfect and got the ideas flowing. And I don't know how I'm going to get to where I'm going yet, but I'm working on it.
Yeah, that's great.
I have an idea.
Okay.
We now have a block. I don't know who wrote it. Somebody wrote it for me at my request, for DHT11, which is a temperature and humidity sensor. You could have the kids make one of those and use it either to track temperature and humidity outside, or if a lot of you have reptiles as pets, which I know a lot of Southerners do, for your terrariums. And you could do that with a flip, so it would not be a real expensive project.
Yeah, and I love the flip. My organization, as it is, we own 12 of them now, and I'm looking to get more. I love the flip. That is a great tool. So, matter of fact, well, no, I'll put mine away.
The DHT11s only cost like $5 and $6 a piece. So.
Okay.
Yeah, and if you want to submerge a sensor, you can always put it in heat shrink tubing with the silicone shield around it. And then maybe an analog sensor would work better. But you're talking about place-based learning, which is really popular, Wayne. So that's the way to go.
Well, I'm looking forward to putting something together. I know the parents are asking for it, the kids are asking for it, and I'm just excited to try to put something together for it. So it'll be a lot of fun once we figure it out.
And I should point out, too, for anyone hanging around, Wayne spends days with the basics, that is reading push buttons and LEDs. And I've seen a number of instructors that do this, and I really advocate it. it's really exciting to get into all the cool stuff, but until you really understand timing in a microcontroller and what's happening, it's harder. You won't know why things fall apart when you try to advance.
Absolutely, yeah.
Hey, Johnny Mac had a question too. Is there a block that allows one to manually insert C code? There is, and I don't know, let's see where it is, but Stephanie will tell me.
I don't know if we've made that one available to the public under the other board type yet, or if it's still just on demo, because it opens up such a very large support can of worms.
It's only on demo.
Yeah, that was my thought, that we will be meeting soon to plan out our next set of releases, and hopefully we'll have a schedule to propose to the public in the next couple weeks on that.
I've been messing with it. Unfortunately, haven't blown up anything yet.
Well, that bodes well.
Okay, so I think we'll wrap up then. Thanks everybody for your time. It was great.
Nice meeting you, Wayne.
Nice meeting you. And this was awesome. Thank you